The 11-30-hour receptacle has 3 blades, 2 hot blades and 1 neutral blade. There is no ground blade. This type of receptacle is commonly used with older equipment that does not require a ground connection. However, using an 11-30-hour receptacle without a ground connection is a violation of the National Electrical Code or NEC. The term 3W connection typically refers to a 3-phase, 3-wire connection. This type of connection has 3 hot conductors and no neutral conductor. With a 3W connection, the equipment does not require a ground connection. If equipment is rated for 3W connection, then it does not require a neutral connection. However, it is important to verify that the equipment is compatible with a 3-phase, 208-volt supply. If the equipment requires a neutral connection, then a different type of receptacle will need to be used. The NEC requires that all electrical equipment be grounded. This is to protect against electrical shock and fire hazards. The ground connection provides a path for fault current to flow back to the source, which trips the circuit breaker or fuse. Firstly, if there is an 11-30-hour receptacle, it is best to replace it with a more modern receptacle that includes a ground blade. Secondly, if equipment is rated for 3W connection, verify that it is compatible with a 3-phase, 208-volt supply. It is essential to always follow the manufacturer's instructions when installing and using electrical equipment. For a deeper understanding, let's delve into the specifics of 3-phase power systems and grounding practices. 3-phase power is a method of alternating current power distribution that uses 3 conductors, each carrying an alternating current signal. These 3 signals are offset in time by 1/3 of a cycle. This configuration offers several advantages over single-phase power, including more efficient power transmission, smoother operation of motors, and higher power capacity. A 3-phase, 3-wire system, often denoted as 3W, comprises 3 hot conductors, each carrying a phase of the alternating current. The voltage between any 2 of these conductors is the line-to-line voltage, which in the described scenario is 208 volts. This configuration does not include a neutral conductor, which is a conductor that is typically at or near zero potential with respect to the electrical source. The absence of a neutral conductor means that the equipment connected to the system must be designed to operate solely under phase-to-phase voltage and does not require a return path for imbalanced currents. Grounding, as mandated by the NEC, is a critical safety measure in electrical systems. It involves connecting the non-current carrying metal parts of electrical equipment to the earth, providing a low impedance path for fault currents. This path allows large currents to flow quickly back to the source in the event of a fault, such as a short circuit. This high current flow will cause the circuit breaker or fuse to trip, quickly de-energizing the circuit and preventing electrical shock or fire hazards. The NEC specifies detailed requirements for grounding, including the size and type of grounding conductors, the methods of connection, and the specific equipment that must be grounded. Section 250 of the NEC covers grounding and bonding, outlining the requirements for ensuring a safe and effective grounding system. The absence of a ground connection, especially with older 11-30-hour receptacles, poses a significant safety risk. If a fault occurs in the equipment, such as a wire coming loose and contacting the metal enclosure, the enclosure can become energized. Without a ground connection, there is no low impedance path for the fault current to flow, and the circuit breaker may not trip. This can result in a dangerous situation where anyone touching the energized enclosure could receive an electrical shock. Replacing an 11-30-hour receptacle with a modern receptacle that includes a ground blade is a recommended safety upgrade. The ground fault circuit interrupter, or GFCI, is a device designed to protect against electrical shock by monitoring the current balance between the hot and neutral conductors in a circuit. If there is an imbalance, indicating that current is leaking to ground, the GFCI will quickly trip the circuit, cutting off power and preventing a potentially fatal shock. GFCIs are commonly used in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. The NEC mandates the use of GFCIs in these areas to enhance electrical safety. When dealing with electrical equipment and wiring, it is crucial to adhere to the manufacturer's instructions and local electrical codes. These instructions provide specific guidance on proper installation, operation, and maintenance of the equipment. Failure to follow these instructions can lead to equipment damage, electrical hazards, and even legal liabilities. Consulting with a qualified electrician is always recommended when working with electrical systems, especially when dealing with unfamiliar equipment or wiring configurations. A qualified electrician has the knowledge, skills, and experience to ensure that the electrical work is performed safely and in compliance with all applicable codes and regulations. For equipment rated for a 3-wire connection operating at 208 volts, the absence of a neutral conductor requires a balanced load across the 3 phases. An unbalanced load occurs when the current draw on each phase is not equal. This can lead to voltage imbalances, overheating of conductors, and reduced equipment efficiency. To minimize the risk of unbalanced loads, it is important to distribute the electrical load evenly across the 3 phases. This can be achieved by carefully planning the placement of electrical equipment and appliances and by using load balancing techniques. In scenarios where a neutral connection is required, it is essential to use a receptacle that provides this connection. A 4-wire receptacle, such as an MA14-30R, includes 3 hot conductors, a neutral conductor, and a ground conductor. This type of receptacle is commonly used for appliances that require both 208 volts power and a neutral return path, such as electric ranges and dryers. Connecting equipment that requires a neutral connection to a receptacle that does not provide one can result in improper operation, equipment damage, and safety hazards. It is also important to consider the ampacity of the receptacle and the circuit wiring. Ampacity refers to the current carrying capacity of a conductor or device. The receptacle and wiring must be sized appropriately to handle the maximum current draw of the equipment. Using a receptacle or wiring that is undersized can lead to overheating, insulation damage, and fire hazards. The NEC provides detailed tables and guidelines for determining the appropriate ampacity of conductors and devices based on their size, material, and application. Section 310.15 of the NEC covers ampacity calculations for conductors, providing guidance on how to determine the appropriate size of conductors for various applications. When installing electrical equipment, it is crucial to properly identify and label all conductors. This includes marking the hot conductors, neutral conductor, and ground conductor with the appropriate colors or labels. Proper identification of conductors helps to prevent wiring errors and simplifies troubleshooting in the future. The NEC specifies the color codes for electrical conductors, with black and red typically used for hot conductors, white used for the neutral conductor, and green or bare copper used for the ground conductor. Ensuring that all electrical connections are tight and secure is essential for preventing overheating and electrical hazards. Loose connections can create resistance, which generates heat and can lead to insulation damage, arcing, and fire. All electrical connections should be made using approved methods and devices, such as wire connectors, terminals, and lugs. These devices are designed to provide a secure and reliable connection that will not loosen over time. Regularly inspecting electrical connections for signs of corrosion, damage, or looseness is also important. Any damaged or loose connection should be repaired or replaced immediately. The NEC mandates the use of listed or labeled equipment. Listed equipment has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories or UL, to meet specific safety standards. Label equipment bears a label indicating that it has been listed. Using listed equipment ensures that the equipment has been evaluated for safety and performance and is suitable for its intended application. The NEC requires that all electrical equipment be installed and used in accordance with its listing or labeling. In summary, understanding the nuances of 3-phase power systems, grounding practices, and the NEC requirements is crucial for ensuring electrical safety and preventing equipment damage. When working with electrical equipment, it is always best to consult with a qualified electrician and to follow the manufacturer's instructions and local electrical codes. By adhering to these guidelines, one can create a safe and reliable electrical system that will provide years of trouble-free service. The information provided here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Furthermore, it is essential to regularly inspect electrical systems for signs of wear and tear, such as frayed wires, cracked insulation, and loose connections. Addressing these issues promptly can prevent more serious problems from developing and ensure the continued safety and reliability of the electrical system. Also, ensure proper ventilation around electrical equipment to prevent overheating. Overheating can damage electrical components and reduce their lifespan. In addition to the specific details discussed earlier, it's important to reiterate the general principles of electrical safety. Always turn off the power at the circuit breaker before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and rubber gloves. Never work on electrical systems in wet or damp conditions. Be aware of the location of overhead power lines and maintain a safe distance. If you are unsure about any aspect of electrical work, seek the assistance of a qualified electrician. Remember that electricity is a powerful force that can be dangerous if not handled properly. By following these safety guidelines and seeking professional help when needed, you can minimize the risk of electrical shock and fire hazards. Additionally, consider the use of surge protection devices to protect sensitive electronic equipment from voltage spikes. Surge protection devices can help to prevent damage to computers, televisions, and other electronic devices caused by lightning strikes or power surges. These devices are relatively inexpensive and can provide valuable protection for valuable electronic equipment. Regularly test ground fault circuit interrupters or GFCIs to ensure they are functioning properly. GFCIs should be tested monthly by pressing the test button on the device. If the GFCI does not trip, it should be replaced immediately. GFCIs are an important safety device that can protect against electrical shock, so it is essential to ensure they are working correctly. Finally, be mindful of the age and condition of the electrical wiring in a building. Older wiring may not be able to handle the demands of modern electrical appliances and equipment. If the wiring is old or damaged, it should be replaced by a qualified electrician. Upgrading the electrical wiring can improve safety and increase the capacity of the electrical system. By taking these additional precautions, you can further enhance the safety and reliability of the electrical system. Electrical safety is an ongoing process that requires diligence and attention to detail. By staying informed and following best practices, you can create a safe and comfortable living environment for yourself and others. And always remember, when in doubt, consult a qualified electrician. Their expertise can provide invaluable guidance and ensure that all electrical work is performed safely and in compliance with applicable codes and regulations. Moreover, proper electrical maintenance is paramount. Scheduled inspections by certified professionals can identify potential hazards before they escalate. This includes checking for loose connections, damaged insulation, and signs of overheating. Proactive maintenance not only prevents accidents but also extends the lifespan of electrical components, saving costs in the long run. Staying updated with the latest electrical codes and regulations is also crucial. The NEC undergoes revisions periodically to incorporate new safety standards and technological advancements. Being aware of these updates ensures that your electrical systems meet the most current safety requirements. Furthermore, energy efficiency should be a consideration in electrical system design and maintenance. Upgrading to energy-efficient appliances and lighting can significantly reduce energy consumption and lower electricity bills. Consider using LED lighting, which consumes less energy and lasts longer than traditional incandescent bulbs. Also, properly insulating electrical wiring can reduce energy loss and improve overall efficiency. Educating yourself and others about electrical safety is an ongoing process. Share your knowledge with family members, friends, and colleagues to promote a culture of safety. Conduct regular safety drills and discussions to reinforce safe practices. By working together, we can create a safer environment for everyone. Remember that electrical safety is not just a set of rules, it's a way of life. By incorporating safe practices into our daily routines, we can minimize the risk of electrical accidents and create a safer world for ourselves and future generations.